Next is electrophilic substitution reaction. That means substitution of electrophiles. Substitution of electrophiles. So, resonance stabilized structure of aniline. Nitrogen atom of amine group which containing lone pair of electrons. Lone pair of electrons. Already we have discussed about the basic character of amines. So, amines are bases. So, bases mean according to the Levy's theory, bases are the substance which donates lone pair of electrons. Acids are the substance which accepts lone or which gains a lone pair of electrons. So, nitrogen atom of amine group here delocalized towards the benzene ring. These are resonance stabilized structures. Then this lone pair shifted towards the benzene ring or throughout the benzene ring. Then again so we give the number to the resonance stabilized structures: first, second, third, fourth and fifth. See here. First and fifth structure both are same. First and fifth structure both are same. Then second and fourth are same. Then third is different. Second and third structures which are ortho-oriented structures. Then third structure is para-oriented structure. Then now we will discuss the electrophilic substitution reaction. That first reaction, that is A. Bromination reaction. Bromination reaction. Bromination means substitution of bromine. Substitution of bromine. So, aniline reacts with bromine in water. Bromine which is prepared in water. So, both ortho position and para position according to the resonance stabilized structure, they are electron rich positions. But bromination ಮಾಡುವಾಗ electrophilic substitution ಆದಾಗ bromine molecule which breaks unsymmetrically to form Br plus and Br minus ion. Bromonium ion and bromide ion. Bromonium ion and bromide ion. So bromonium ion which attacks to ortho position as well as to para position to form So here, 3 bromine atoms attached to all the 3 active groups, active position in the benzene ring. That means 3 bromine molecule react with 1 aniline molecule in water molecule to 4 plus 3 forms 3 HBr. That means Br minus combines with hydrogen atoms replaced by Br plus ion to form HBr. Then this is called as 2,4,6 tribromo aniline. 2,4,6 tribromo aniline, or simply it is called 2,4,6 TBA. 2,4,6 TBA, tribromo aniline. So, because NH2 group, which is electron rich group, that donates electron density towards benzene ring, hence electrophilic substitution reaction takes place towards all the 3 positions. To protect the activity, to reduce the activity of NH2 group, or to prepare the mono-substituted product instead of tri-substituted product, if you want to prepare the mono-substituted product, first the activity of NH2 group is reduced because NH2 group is highly active. So their activity, if you reduce it, then instead of forming tri-substituted product, you may prepare only mono-substituted product. Then again reaction, another reaction, bromination, that is CH3 C11O C, that is acyl chloride. Acyl chloride. So first direct ಆಗಿ ನೀವು ಬ್ರೋಮಿನೇಷನ್ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು acyl chloride preparation treatment ಇದ್ರೆ ಅಂದ್ರೆ so amide formation ಆಗುತ್ತೆ. That is so one of the hydrogen atom which is replaced by acyl group. So acyl group treatment daga, so ಇಲ್ಲಿ ಏನಾಗ್ತತಿ ಅಂದ್ರೆ the activity of NH2 group is reduced. ಇಲ್ಲಿ ನಾವು activity of NH2 group ಅನ್ನು reduce ಮಾಡಲಿಲ್ಲ. So ಇಲ್ಲಿ ನಾವು reduce ಮಾಡಿದೀವಿ ಅಂದ್ರೆ so again this is treated with bromine in water. Such compound is treated with bromine in water, or this is called as phenyl acetamide. Phenyl acetamide ಗೆ bromine in water treatment daga will give the product NH C double bond O CH3. So this is minus HBr. So this is para-bromo benjamide, methyl para-bromo benjamide formation ಆಗುತ್ತೆ. So again ಇದನ್ನ ಮತ್ತೆ ನಾವು ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಮಾಡ್ತೀವಿ, alkylation ಮಾಡ್ತೀವಿ. So this is treated with HCl. acid ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ acid ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ again we will get back CH3 COCl. So to form C double bond O C. So the function of acyl chloride, here is to reduce the activity of NH2 group. This acyl chloride reduces the activity of NH2 group. So first this amide is formed, then amide is treated with bromine to form bromination, that is para-bromo substituted product. Then again the deacetylation is formed by the treatment with HCl. So ಇದರ function ಏನು ಅಂದ್ರೆ NH2 group ಇಲ್ಲಿ active ಇರೋದ್ರಿಂದ all the 3 positions substituted by the bromine. ಈಗ ನಾವು ಒಂದೇ position ಗೆ substitution ಮಾಡಬೇಕಾಗಿತ್ತು ಅಂದ್ರೆ first the position of the NH group is blocked. Their reactive activity is reduced by CH3 COCl. or ಯಾವುದೇ ತಗೋಬಹುದು, acyl chloride ತಗೋಬಹುದು, benzyl chloride ತಗೋಬಹುದು, acetic anhydride ತಗೋಬಹುದು. ಯಾವುದೇ ಅಸೈಲ್ ಗ್ರೂಪ್ ಇದ್ದಂತ ಕಾಂಪೌಂಡ್ ಅನ್ನು ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ the activity is reduced then when it is treated with bromine to form para-bromo substituted product. Again we will remove the acetyl chloride by treating it with hydrochloric acid. So these are the two different reactions takes place during the bromination reaction. So you block ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ tri substituted product ಬರ್ತತಿ. ಇದರ reactivity ನ block ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ mono substituted product ಬರ್ತತಿ. But the percentage of para-bromo substituted product is more than the percentage of ortho substituted product. Ortho substituted product the yield ಕಡಿಮೆ ಬರ್ತಿರ್ತತಿ. ಯಾಕೆ yield ಕಡಿಮೆ ಬರ್ತೈತೆ ಅನ್ನೋದಕ್ಕೂ there is a reason, because this is the bulkier groups. Due to steric hindrance, the substitution group pulls away, then it attacks to the para position. Then next is nitration reaction. Second reaction, that is very important reaction. So aniline. Aniline which reacts with nitric acid in presence of H2SO4, nitric acid. But this reaction is a little bit typical reaction comparing to bromination reaction, because here there are three products are formed. So this is para-nitroaniline plus metanitroaniline plus orthonitroaniline. Now already discussion ಮಾಡಿದ್ವಿ. According to resonance stabilized structure, only ortho position and para positions are highly active. So the electrophilic substitution reactions takes place to only ortho as well as to para position. Ortho as well as to para position. But in this case, during the nitration reaction, meta-nitro position, meta position is also substituted by nitro group. Why? Because during this is base, organic base, and this is the inorganic acid. So acid when treated with base to form anilinium ion, acid reacts with base to form anilinium ion. That is, anilinium ion is NH3 plus ion. NH3 plus ion, this anilinium ion is para-oriented product. Anilinium ion is para-oriented product. Hence, aniline when treated with acid, that is HNO3, to form para-nitroaniline, mixture of para-nitroaniline, meta-nitroaniline as well as orthonitroaniline. This reaction is called as Terry-oxidation reaction. This is also called as Terry-oxidation reaction. During Terry-oxidation reaction, meta-nitroaniline is formed by the formation of anilinium intermediate product. Intermediate product is anilinium ion, but anilinium ion is meta-oriented product, meta-oriented substance, hence para, meta and orthoanilines are formed. But the percentage of these three compounds, here the percentage of para-nitroaniline is 51% product is formed. 51% product is formed. But meta-nitroaniline is 41% product is formed. But orthonitroaniline, which gives only 2% product. Orthonitroaniline forms only 2%, because the intramolecular hydrogen bonding takes place between NH2 group and NO2 group, because these two groups which are present side by side. Hence intramolecular hydrogen bonding takes place, hence the yield of the product quantity is reduced only 2%, and higher percentage here is 51%, that is para-nitroaniline. One ಸ್ವಲ್ಪ confusion ಇದೆ, careful ಆಗಿ observe ಮಾಡಿ. Bromination ಮಾಡಿದಾಗ ortho substituted product as well as para substituted product formation ಆಗ್ತತಿ, meta substituted product ಆಗೋದಿಲ್ಲ. But nitration ಮಾಡುವಾಗ ortho substituted product, para substituted product, along with these two products there is one more product, that is meta substituted product. This meta substituted product is formed due to intermediate formed product formed in the reaction, that is anilinium ion. This is called as this anilinium ion is formed during the intermediate reaction. So this is meta oriented. Hence all the three substituted products are formed during nitration reaction. So ಸ್ವಲ್ಪ confusion ಇದೆ, ಇನ್ನು careful ಆಗಿ observe ಮಾಡಿ. The electrophilic substitution reactions takes place in all the three is different. Then next is sulfonation reaction. One more reaction, it is sulfonation. That is very simplest reaction. Sulfonation. Substitution of sulfonating group. Substitution of sulfonating group. So here aniline reacts with sulfuric acid. Aniline reacts with sulfuric acid. So sulfuric acid is strong acid and aniline is base. A base reacts with acid to form salt. First it forms NH2HSO4. NH plus HSO4 minus. That is anilinium hydrogen sulfate. Anilinium hydrogen sulfate. So this again reacts with H2SO4. Again reacts with H2SO4 to form NH2SO3H. NH2SO3H. This is called as para amino benzene sulfonate. Para amino benzene sulfonate. This para amino benzene sulfonate, so it interchanges, very important here, it interchanges. This is acidic group and this is basic. SO3H is acidic group and this is basic group. So this acidic group which donates H plus ion and basic group which gains H plus ion. During the transaction of H plus ion from acidic group towards basic group, NH2 converted into NH3 plus ion, and this donates H plus ion and it converted into SO3 minus ion. SO3 minus ion. Both acidic group as well as basic group. Acidic group, basic group, both are present in the same compound. During that time, the transfer of H, according to the Lary-Bronsted concept, acids are the substance which donates H plus ion, bases are the substance which accepts H plus ion. So acidic group donates H plus ion and basic group accepts H plus ion. So there are ion is formed, dipolar ion is formed. So that dipolar ion, it is simply called as Twitter ion. Dipolar ion, it is called as Twitter ion. I think in the ion, Mr. Demetri, that is in case of amino acids. Amino acids nalli bardati. Twitter ion is Twitter ion means the dipolar ion formed by transfer of acidic proton and gain of acidic proton, which takes place within the molecule to form a dipolar ion. That dipolar ion is called as Jutar ion. So this is about the sulfonation reaction. Sulfonation reaction takes place. First the sulfonation ಮಾಡುವಾಗ H2SO4 treat ಮಾಡಿದಾಗ H2SO4 directly attached to NH2 group, that is aniline hydrogen sulfate is formed. That aniline hydrogen sulfate again treated with hydrochloric sulfuric acid to form para-amino benzene sulfonate. That para-amino benzene sulfonate, which is a dipolar compound, hence it forms Jutar ion. So here we complete the electrophilic substitution reactions of aromatic primary amines. Aromatic primary amines, there are three reactions. One is bromination reaction. Bromination ನಲ್ಲಿ ಎರಡು reaction ಬರ್ತಾವ. So bromine in water treat ಮಾಡಿದಾಗ TBA, tribromoaniline is formed. So ಅದೇ tribromoaniline formation ಮಾಡೋದು ಬದಲು ನಾವು monobromoaniline formation ಮಾಡಕ್ಕೆ ಹೋದಿವಿ ಅಂದ್ರೆ first aniline group is blocked by acyl group. So acetylation ಮಾಡಿದಾಗ so monobromo ಆಗ್ತದೆ. Then nitration ಮಾಡುವಾಗ again different reaction. Paranitroaniline, metanitroaniline and orthonitroaniline, that is called as carioxidation product. Paranitroaniline percentage of yield is 51, metanitroaniline percentage of yield is 47, then remaining 2% which is orthonitroaniline. That metanitroaniline is formed by formation of aniline ion during the intermediate reaction. Then sulfonation ಮಾಡಿದಾಗ Jutar ion formation ಆಗ್ತದೆ. Now today we will stop the electrophilic substitution reaction. In the next class we discuss about diazonium salt formation. Diazonium salt ಅಂದ್ರೆ so benzene ಅನ್ನು ನಾವು again treat ಮಾಡಿದಾಗ sodium nitrite ಜೊತೆಗೆ ಅಥವಾ nitrous acid ಜೊತೆಗೆ already I was discussed in the distinguishing test between primary, secondary and tertiary amine. So aromatic primary amine when treated with nitrous acid to form benzene diazonium chloride. That benzene diazonium chloride is vast applications in the organic chemistry. That compound is used to prepare so many organic compounds using benzene diazonium chloride. So we will discuss in the next class. Thank you.